Hey, this is Derek with the Namespace Podcast, episode 7, and I'm joined with my co-host,
Jordan.
And today we're talking about technical debt.
Yes.
That thing that every developer wants to avoid.
Mm-hmm.
So we're going to rethink it today. Everybody knows what technical debt is. You have a gut feeling, but we are going to rethink some of the norms about technical debt. Mm-hmm. So to start off, we're just going to read what's the Wikipedia definition of technical debt, and then we're going to go from there. Mm-hmm. You have it written down, so you go.
Yep. The implied cost of additional rework caused by choosing an easy solution now instead of using a better approach that would take longer. So that's kind of the baseline for technical debt and what it means. And then we have to talk about why to address technical debt.
Right.
One of the main things that everybody's always thinking about, it's expensive to maintain. And
not maintain technical debt, but maintain the code base with technical debt, right?
Yeah.
Okay.
Yeah, it's expensive to maintain a code base that has a lot of issues where people took fast and easy approaches instead of doing things the right way. It just becomes really complicated. And it's also, whenever you have a lot of technical debt, your code base is at risk for defects. It's much easier for bugs to come about whenever you have a lot of quick and easy solutions that don't make as much sense or aren't as solid of solutions.
Right. And by solid, she's referring to the solid design principles.
I figured you'd think that. I was trying to think of a different word.
Not everybody knows solid. So we're going to plug Jordan here. She is going to be talking at the Austin Python meetup and presenting a Pythonic guide to solid. Mm-hmm. So congratulations, Jordan.
Thank you.
But originally, the guys who were running the meetup didn't know what solid was.
Really?
Yeah.
What?
So
that's crazy.
That's why I had to, say it. Not everybody knows what solid is.
Yeah.
Tangential though. One of the other things you were talking about, well, no, I'm going to reserve this. I'm going to wait till another point.
Well, you have a theory. That's
right. Okay. I forgot. I do have a theory on this. I want to read it.
Yeah, go ahead.
We wrote it down. I want to read this one because...
Can you read it from here?
The way I put it down is, paying off technical debt is an exercise of empathy and technical ability. Developers will either add value by making the code better or gain stronger understanding of the technical problem that created the debt to begin with. Mm-hmm. And when it comes to technical debt, clean code, quality code, one of the themes running throughout it all was developer empathy. Mm-hmm. And that's the writing code with the thought of the developers behind you, mm-hmm. like who's going to have to work with it next. Conveying the feeling and that knowledge and understanding to somebody else, and also understanding that knowledge and feelings from other people.
Yeah.
And so part of that is another way I put this was, technical debt with a reason is better than technical debt because of laziness.
Yeah.
And that's part of the empathy part. As you dig into the technical debt, once you get past the surface level, you're going to hit the root cause of why that technical debt was there to begin with. And that is either going to be a very difficult technical challenge that you didn't understand yourself, or that developer didn't understand when they first started, and so they made the workaround, or you're going to uncover that it was just laziness, mm-hmm. probably a lack of test-driven development, a lack of design ahead of time, a mm-hmm. lack of requirements, and so code was just added, and then by the time the feature was done, they were frustrated and done with it, and they're like, I'm not going back to refactor at this point. Through this process of paying off technical debt, you develop that empathy, which I think, and we kind of came through, or both came to realize going through this, is very important, is that developer empathy.
Yeah. Like as a developer, picking up technical debt tickets and building a cleaner code base is just going to be it's good for every developer to understand what a good code base means. So it's like identifying the things that need to be fixed and making them better is a huge process that's important for everyone on the team to realize what is considered good code on this team. The standards we're going to uphold too.
Yeah.
So yeah, besides just that perspective, expensive to maintain all those issues. We will talk about more stats later on for why not addressing technical debt is expensive and why you should address it.
Yeah, those people that follow the @namespace_pod handle on Twitter, they got a sneak peek of the big stat already. We tweeted about that.
Yeah.
So, just saying, if you want the sneak peeks, the 411, follow us on Twitter.
Cool. So now that we've talked about why it should be addressed, let's talk about why does it exist? And I think a really fundamental reason can be explained by Lemon's laws, or two of them.
Was it Lemons or Lehman's?
It's probably Lehman's.
Okay.
Lemons is like a fruit. So
it's Lehe.
Lehmen.
Yeah.
Lemon.
So Lehmen.
Lemon's law.
Lehman.
Oh, Lehman.
I don't know. I'm going to say Lehman. You say Lemon. I don't care.
Well, he's got some laws, and two of them are: a system must be updated over time to add new features for users and to remain competitive. Also, a system becomes increasingly complex over time and more difficult to maintain. So when you have both of those laws in effect together, what happens is you need to continually update your code, but it's difficult. And to reduce that complexity, you can address that technical debt and organize your code base to work for the new features you need to add.
So I think this is a great spot where I'm going to now bring in my other theory. And this one isn't as elegantly put, but the code base as it grows in complexity over time, if you're not fixing the technical debt, you then have developers that don't read and understand the code to a deep enough level. And so then they just start adding layers and kind of hiding the technical debt. And then that just compounds the problem infinitely.
Yeah.
And so it's a little bit of like why there's technical debt is people didn't read the code, but some of like what is technical debt, why you want to fix it is not fixing technical debt is a positive feedback loop and it's still not reading the code and still adding more technical debt.
Yeah, totally.
And making it worse.
Yeah. If you don't address it, it's not going to remain stagnant. It's going to get worse and worse and worse and worse. Cool. So some other reasons why technical debt exists. For one, we've talked about just tying yourself down to a language or a framework is a form of technical debt. We already referenced this earlier in a different episode when we said that Go is rethinking the technical debt by kind of the idea is that you would make a new repository and refactor your code to work for each version, like completely brand new.
Right. That and also writing code that is framework agnostic.
Yes. That's another huge part.
And this is part of the rethinking of the technical debt. Most of the time, choosing a language, choosing a framework isn't thought of as technical debt. It's thought of as a tool and an asset. But because these are things controlled by third-party entities, once they do any kind of major upgrade and you have a jump from, Python 2 to Python 3, and Python 2 is now out of support, you're not getting security patches, this becomes a business problem because you'll have contractual requirements to keep your product supported for security patches. Some compliance and regulatory committees, are going to require you to have that stuff. And you could lose customers, come up to penalties and fines if you're not keeping these things supported. So as soon as you choose one of these things, you've also accepted that you have to keep pace with whatever language framework you've chosen. and you choose one of those that's iterating really, really fast and moving really quick, you've chosen that we are going to keep pace with them. And that is a form of technical debt that most people don't think about.
Right. And Derek was talking about from a customer's perspective, there are reasons to have to keep up with the changing technology, but also from a developer's perspective, it's like, nobody's going to want to work for your team if you're on some version of a product that's like super old and like everything's outdated. Like you want to keep a high morale and keep people interested. So that's kind of another reason why
we're geeks, we're nerds. We like the new shiny, cool, fancy things.
Keep us interested. If like the good developers are going to want to work with cool technologies. So tie yourself down to some cool technology.
So another portion of rethinking the technical debt that goes hand in hand with this, and one that I ran into recently, is things as easy as like choosing an algorithm or coming up with an algorithm or a method for analyzing data can be technical debt. And then the case that I ran into was this thing took inputs from 4 other services in the system, and it had an algorithm and a method for choosing a classification of something. And then it wrote that to the database, and it became a matter of fact that this is what happened.
This is the classification of the thing.
Yeah. And now I'm in middle of writing version 2 of this thing, and having reverse engineered it and looked at it, is like, wow, this is incredibly inaccurate. And it doesn't really have any hope of accurately picking a classification.
Yeah, the classification was poor.
So the algorithm and the method was poor, and there were some technical debt issues, like people weren't reading the code or whatever that led to this. But now in version 2, I have options, which is I can either write version 2 in a way that if the same inputs came in, it would come out with the same artifacts, the same things that were written to the database, or I have to write the migration converter, whatever, that takes that old data and makes it compliant to version 2.
Yeah.
Now, in my case, I can just rerun the inputs. All that stuff is still stored, but that's not the case all the time. And so you can have a really big problem there. And we're going to talk about it later, but like the solution to that is data versioning, where you track the version of the algorithm of the product that produced that data.
Yeah.
And that way you have the reference and the understanding how something got that way.
Yeah. So you have the option to treat something, an artifact, differently based on what version produced it.
Yeah.
But yeah, keeping track of versioning is going to be a very important way to rethink technical debt. And we'll have some more examples involving that as we go along.
Yeah, that's another one of those themes that came out a lot, versioning. Lots of versioning.
Totally. Cool. So now we're going to talk about how to identify technical debt. So there are some symptoms of poorly written code that should be refactored, and that's kind of, you can identify technical debt that way. Some of these symptoms, most of these symptoms are basically like you're not following the solid principles. So you have a module or a class with really low cohesion. There's a lot of responsibilities all put into that same file or class, and they don't really go together. That class has a lot of reasons to change. That's right. One way to identify.
Overall, not following the solid design principles. We haven't done our episodes on solid, have we?
No, we will though.
So we're just going to list them right here. It's the single responsibility principle, the open-closed principle, Liskov substitutability principle, interface segregation principle, and the dependency inversion principle. So those are the 5 that you can look up, and there's lots and lots of articles and videos and things about them. But when you follow those, you tend to avoid
technical debt.
There's still technical debt in there. Like, don't take it as, if I write solid code, there is no debt. There's still debt there. But it's more manageable. Right.
I mean, there will be debt as your software, as you add features and as it becomes more complex. It's just got to make sure to address it. So, not following solid. I mean, things like tight coupling. I've read from a few different sources now, deeply nested inheritance is a kind of a red flag for code that might need to be refactored, because all of these classes are technically different classes, but they're tied to each other very closely with this inheritance.
Well, yeah, inheritance is almost glued together.
Yeah.
That's how tightly coupled. There's ways to break it apart, but it's all or nothing with inheritance. But the deeply nested inheritance always
deeply nested logic, or just deeply nested conditionals, that type of thing,
so
right?
Two different things: inheritance and then the conditionals and loops. When you have too many nested loops and ifs, that's definitely bad.
That's stuff that needs to be refactored.
In fact, on the product that I'm writing version 2 of, you were 5 for loops deep. Oh. Just imagine that code, right? 5 for loops deep.
Oh no.
And that's not even the conditionals as well. That's just the for loops, and there's ifs and elses and but the deeply nested inheritance. So if you have an inheritance structure of 5 to 6, at first I'm like, I don't know if I agree with it. That's kind of what the open close principle is telling you. But then I thought about it a little bit harder. And really, if you need to go that many levels of inheritance, your original abstraction probably wasn't refined enough. And so I'm saying 2 to 3 layers is probably as much as you should ever need. And don't take this wrong as you've failed as an engineer if you have 4 or 5. It just means you've now learned a lesson, and you just have to derive that lesson out of what just happened with your code.
Yeah, it's the abstraction may have been good the first time around. Maybe you only had a few layers of inheritance, but as you add more features and as the code changes, if you realize that your gut feeling is, I should add more levels of inheritance, well, maybe that's not the solution. Maybe the solution is to redefine that base class and separate out those abstractions. Yeah. Oh, well, you don't like base classes.
Well, I mean, I don't like things named base, like base animal, or it's okay, now you're tangent for another day. I'm not saying that you go in there and fix it right that second, because with all of that inheritance, that's a huge change you're taking on. But you've learned what was it about that parent class that I did wrong? I implemented it wrong that caused for this inheritance to end up like that. Or what was the business process that allowed for that to happen? And then you can correct those in a sprint retrospective or something. And I'm not saying you have to fix it, that particular problem right then, but it does teach you a way to avoid it in the future. Yeah.
Well, what I was thinking was more what I was saying was more than before you implement that subclass of a subclass of a subclass, just don't do it. Just have a different solution. Before it even gets to that point, maybe refactor before you get to the 7th subclass. Maybe you just have a few and you're okay, I want to add more, but I will refrain and I will consider what would be a better solution than making this deeply inherited.
Yeah, for sure.
That kind of ties into another point that we're going to bring up, which is just to avoid technical debt, just doing things right the first time. And the Boyscout principle, which I wonder if that's on our next section.
So we haven't talked about
we'll wait for that.
Cyclomatic complexity yet for identifying.
Yeah, we can talk about that now. So
we're still, how do you identify technical debt? I got us off on a tangent. I apologize, but cyclomatic complexity is measuring the number of workflows through a function or a class, you know, in your code base, a module, whatever delineation you want for measuring it. And the more workflows or paths through it, the more complex the code is. That's really what that comes down to. There's a ton of static analysis tools that do it. Pretty sure that falls under static analysis. But there are tools out there that will calculate what your complexity is that way.
Yeah. So just besides the symptoms of code that, like, as a developer, you can see that this might need to be refactored. There are more quantifiable ways, like the cyclic complexity thing. Something that's very complex should probably be refactored.
I don't know if it was a talk you listened to or something, but they talked about the coupling. Remember you showing me a picture of like two stars growing at the same rate, and two services were like coupled?
Yeah.
Like there's that way of doing it.
Yeah. So I'll just mention, like, the talk I listened to was by Adam Tornhill. He had a talk called Prioritizing Technical Debt as if Time and Money Matters at the GOTO conference 2019.
Oh, okay. GOTO is good conferences.
Yeah.
They do them in a bunch of different places. I think the original is Chicago.
Oh, okay.
Yeah.
This one was Copenhagen, so I guess they're everywhere.
Lots of good talks at GOTO.
Yeah. So, well, I'll mention, before I talk about like the stars next to each other thing, this guy, Adam, said that one way that he measures complexity is the cyclomatic complexity times the number of times that code has been updated lately. Let me see if I have it. Just code change frequency, basically. Yeah. So those two things together can give a really good idea of an area of code that needs to be refactored. So he'll typically make graphs where you can see a specific file, and the size of the file on the graph is bigger if it's more complex based on that measurement. And so you can kind of visually see where that complexity lies in your code base. But then the other one is the change coupling.
Yeah, that's the one.
Yeah.
So whereas if a change to service A generally causes a change in service B, those two things are coupled, and that's a technical debt.
Mm-hmm. Yeah. So he called that change coupling. And I'm pretty sure that his analysis on that was based on monitoring Git commits, doing a lot of logic with the Git command line and receiving data. So it's just, if you have two different services that are getting changed a lot at the same time, then that interaction between those two services is coupled. And you don't want that, because that in coupling lies technical debt.
Dependencies.
Yep. Reducing your dependencies. So that's another way to measure it, is by monitoring change coupling between services. And then something else that's super important for identifying technical debt. Of course, just a gut feeling from developers. Oh, yeah. If you have a room full of people and a room full of developers on a team, they can usually all agree what's the thing that should be refactored first. Like, everyone has this idea in their head.
They may not all agree on it, but they all have an idea of like, oh yeah, that needs to be fixed. Mm-hmm. Sometimes maybe they don't want to talk about it. And that's how, as a manager, like if developers don't want to talk about code, they don't know what's going on.
Yeah.
And that kind of transitions us into the next point, is just because you don't understand code doesn't mean it's technical debt. Mm-hmm. It's just understood.
Yeah, that's huge. Because you can have, you can notice all these things in code that you think is bad, like not following the solid principles, or like the tight coupling stuff, or even these statistical values that you can measure. But just because code doesn't make sense to you does not mean it needs to be refactored. Like, and that's something, like, you have your gut feeling, and that can be accurate, right? Like that is a good way to measure technical debt, but it can also be inaccurate, because like if an entire team, just as an example from this talk, if an entire team takes on a project from a different team, at least in this example, they thought it was a poorly written project because they didn't understand it. They were like, we didn't write this code. We don't understand why all these decisions were made.
I think it's also such a problem in industry that we're all just so paranoid, like, oh, somebody else wrote this. This is terrible.
Yeah.
Like,
yeah.
We're all car mechanics, really. I've never met a car mechanic that agrees with how another car mechanic did something.
Yeah.
So it's, oh, well, that person messed it up and screwed. They should have done it, you know, where we're exactly like that. Oh, they didn't do it this way. That's terrible.
Yeah.
But objectively speaking, yeah, inherited code can actually be good.
Yeah, it can be. So don't mistake code that you don't understand for code that is written poorly or should be refactored or is technical debt. It might not be. Cool. All
right, so we're moving on to the next section now. You had mentioned, I'm blanking on it now. We got to go 2 or 3 points back.
I think I know what you're going to say.
Say it then. Fill in my brain.
I was saying to approach technical debt, there's kind of 2 perspectives: how to approach technical debt as a developer versus how to approach it as a team lead or a company.
Yes. And the point you made was, again, from that Adam Tornhill. Was it Adam Tornhill? Adam Tornhill. What did you say? Where he measures how many changes are happening to a file. And then it comes to the handling technical debt as a developer, the Boyscout principle, which is you always check in code cleaner than what you checked out. And this specifically applies to paying off technical debt, because if you're working in a code base that has none, you know, a theoretical one, there's no way for you to check in cleaner code. But as you follow the Boyscout principle, you don't fix everything about the code. You don't make it perfect. Then it's not testable because of this. Well, okay, fix that problem so it is testable. Let the next person come back and write the test. And you'll notice that as you do this, the code that you're changing and applying the Boyscout principle to is becoming better. And the code that you're never touching, which may still be technical debt and bad, is not changing because it's stable now. Yeah. And that was another element to that talk I remember you mentioning, is code either rots or grows stable. And through the Boyscout principle, you find out what was rotting and got fixed, and then what was just becoming stable.
Yeah.
So that's one of the ways as a developer you can start to address the technical debt in your code base. Yeah,
just like small pieces at a time. I basically don't introduce new technical debt, and when you need to make changes, make it better. Yeah. Improve your code base. One of those stats from that talk that Adam Tornhill had, the idea that code either grows old and rots, kind of just never gets used anymore, and then you can delete it, or it becomes stable because it's used all the time, and over time people fix the bugs, because whenever a bug is found, it gets fixed, and then just ends up being a module that's used a lot and it works. With the statistic he had was old code, specifically a module that is 1 year old will have 1/3 the faults of a module that's written brand new. So
it'll have 1/3 less.
A third of the faults.
Oh, 2/3 less. So a module that's a year old has 2/3 less bugs than a brand new module.
Yeah. So that kind of goes to show the whole idea that code you don't understand or code that you haven't written yourself might be fine, because a lot of times if code is really old, nobody's touched it in a while, and maybe nobody understands it because the guy who wrote it left. Doesn't mean you just have to completely rewrite it because you don't get it. If it's working, even if you don't get it, it's working and it's fine. Old code can be good. Statistically, that's what this says. If it's been around and it's been working.
Can be, not always.
Yeah, it kind of, there is a little bit of a contradictory there, because we've also had the conversation where code that everybody's trying to avoid, and the code that's just left in the code base forever, and people try to avoid it because they're worried they're going to break something in it because it's so brittle, and it's like nobody wants to touch it because they're worried. It's like,
see, that's that gut feeling.
Yeah. So I guess it can go both ways, but for the most part, it kind of just comes back to the point that don't assume that something needs to be refactored because you don't understand it. Anyway, so the approach to technical debt as a company or team lead, we can talk about now. So something that's important here is to not quantify technical debt over a whole code base, because that's overwhelming, and it's not okay. Technical debt's incredibly important, but it's not important to fix all the technical debt at once. It's like you still need to be putting out new features, right? So the idea from a company or like, you know, a team lead perspective.
It's that adage, how do you eat an elephant one bite at a time?
Yeah, totally. And so if you're like a team lead and you're the person, or a product owner, if you're the person who's prioritizing tasks and prioritizing technical debt, take it one step at a time. And the first piece that you want to pick would be the one that adds the most value or the most impact. So with Adam Tornhill's approach, where he makes these graphs and calculates the complexity times code change frequency, you can see which file has the greatest complexity times code change frequency. And that's usually the one that would be best to address first, that will provide the most impact. So you kind of want to go about it in that type of way, by picking and choosing and not trying to just solve all of the technical debt at once.
Yeah, and on the micro scale of that is the Boyscout principle. Don't fix all of the issues with that. Just like fix one of those that makes it cleaner, and then let that module over iterations grow better.
For sure. Cool. And then one other thing that we thought, companies and team leads can do to help with technical debt, which I also kind of got this from the Adam Tornhill talk. We watched it right before this, and I thought it was really, really good. We'll put a link in the description.
His specialty was technical debt. Like, he consults with companies on their technical debt.
Yeah.
So he's definitely a subject matter expert in 100%. The field of technical debt.
Yeah. So I like what he says. I mean,
we'll include a link to that talk.
Yes.
I only saw the last 15 minutes of it, but
we're going to talk about so many points from it, but definitely watch it. So yeah, the other thing he was saying, which kind of extends on the idea that code you don't understand isn't bad code, to avoid that happening, and developers not wanting to touch code because they don't get it, what you can do as a team lead is, if somebody is going to be leaving the team, you can figure out what packages or files or classes, what areas of the code base that person is a major contributor to.
Get blame.
Yeah. So figure that out.
It's a really poor name for that utility.
Technically,
you're blaming them, but it comes with a very negative connotation. And I don't think it should.
For sure.
But to that point, the way that you can also identify these subject matter experts is through something we've already mentioned, which is feature ownership. And as a company team lead manager, you should be promoting feature ownership, which is when a developer owns a feature from inception to obsolescence. So from when it's being designed all the way through development, maturity, to no longer used and deleted from the code base, they are the owner. It helps with delegating tasks of that feature to somebody, communicating the architecture, the design, the limitations with it. It allows you to understand, as a manager, it allows you to understand where the good quality code is coming from or the poor quality code is coming from.
Yeah.
And that's not necessarily as he writes bad code, we need to fire him. It's probably more of there's some sort of training deficit here. This person, should be paired with a senior, or maybe they are misunderstanding what the solid principles are, something like that. But then in line with what Adam Tornhill was saying, that you now have somebody who has new team members come on, can onboard them with that feature, But when they go to leave, instead of just leaving this gap of knowledge, well, they're a feature owner of, X, Y, and Z, so they need to do a knowledge transfer before leaving. Mm-hmm. That's not always going to be the case.
Yeah.
Sometimes people leave with a day's notice.
Oh, that's true.
Or sometimes people get fired for other reasons. Sometimes people get hit by planet-shattering asteroids and, they can't. But in the cases that you can, it allows you to make that smooth transition early.
Totally.
And then as a developer who is one of these feature owners, you really need to have that developer empathy that we mentioned earlier. Be thinking about the developers that have to work in this code after you. And then you just need some codecraft disciplines.
Totally. Yeah, so that's like the next topic we are going to get into, besides how to approach technical debt from a company or team lead perspective, the idea of how to pay off technical debt and avoid causing technical debt as a developer, Boyscout principle, like you said, and strong codecraft, like you said. I mean, just doing your best all the time. Come on, everyone, just do your best all the time.
Now, okay, so in the industry, there's this battle that we all know about and we don't talk about it enough, is that developers want to slow down, like, oh, we can never meet that deadline. And business like, well, you have to meet that deadline. We have a process issue of, oh, well, developers are going to go through Scrum and we're going to pad the amount of work by 2 weeks. And then management knows we're padding it by 2 weeks, so they're going to cut it down by a week and a half. And we have this cycle of racing who's padding the most. And really, it comes to this point where as the developer, you're the ones with the knowledge, and you can say that can't happen. Mm-hmm. Like, no. Managers don't like it. I've told no to a couple of managers before. Sometimes it goes well, sometimes it doesn't. But that's really how it should be in the industry. It's like the developers understand the technical space of where we're working. Mm-hmm. And okay, so I didn't come up with that. It's been intuitive to me, but Uncle Bob, personal icon of mine, is the one that very bluntly states that as the developer, you have the power to say, no, that can't be done, or we need to do it this way. And he cites the case of the Affordable Care Act site going online, and then it almost immediately crashed, and it almost caused the whole bill to be rolled back because it was so, like, the technical challenges were so bad.
Okay.
And what happened, and I'm almost quoting him at this point, but it is absurd that it was signed into law that a software system would be done by X date. Every developer out here knows that's a terrible idea and you can't do it. I mean, they did, but we saw the result. But then you need to think about the developers. Like, who are the developers that let them turn it on?
Yeah.
Like, they already knew it was a stupid idea that you were giving us this deadline before talking to the developers. Okay, I can't say that. I don't know if they did. But, like, the developers had the power to say, no, it's not ready. It's not going to handle the load.
Yeah.
But nobody said anything. And
maybe they were yelling and didn't want them to, but turned it on anyway. It's just this huge conflict.
It could be. But that is the case study that Uncle Bob uses, as the developer should have the power at some point to be like, no, this can't happen. This isn't safe. This isn't ready. Yeah. Because we are the ones that know. Yeah,
there is a huge, in the industry, kind of a huge issue from, I think, every developer's perspective, where it's like so many companies, put the feature complete priority before the feature done correctly priority. And that's just a huge problem, like, overall, that maybe we could even have a whole episode on that just in general. Because I think that that's, like, within the industry, just the biggest deterrent is like, I know how to do this right. Just let me do it right.
Yeah.
That would help with technical debt big time if you just had the time to do things the right way the first time. Well, there is a cost to technical debt. And there's a cost to not doing things the right way the first time, and we'll get to that. There are numbers. Yeah. So.
No, I'm sorry. I went on another tangent.
No, it's okay. It's important. No, we're talking about important stuff. People want to hear it.
For sure.
Okay. So yeah, next, we had a little section where we were just going to talk about microservices because there are some specific actions you can take with microservices to help with technical debt, like the change. Change coupling? Yeah, the change coupling monitoring stuff. That's more specifically for microservice architectures, where you have a lot of different interfaces between applications that talk to each other. And a huge one, again, we're going to come back to versioning.
Version your endpoints.
Yeah, version your endpoints. So the idea there that we've talked about is that you will be able to decide when you want to take on technical debt. So if you're a service and you're importing some other services, or you're making calls to those services, you can make a call to like a specific version of that service, right? And maybe that service undergoes a bunch of changes. You don't necessarily have to change everything about your service immediately. Like you can work with the new version and make the updates for your service to be compatible with the new version when you have time to as a team. So that's helpful. Just keeping all those versions really specific and keeping track of that.
And because we came back to versioning, I didn't actually... Well, I guess I did talk about data versioning, didn't I?
Yeah.
It's just where you slap a version on, this is the algorithm or the product that... The version of the product at the time it created this data. So, you defer when you want to handle it. Without that version is, well, I got to make it work with the new stuff.
Yeah.
Compared to like, oh, I just now conceptually understand it's old. And that's what the versioning of endpoints and microservices and APIs does. It allows you or whoever is consuming that API to defer when they handle paying off that technical debt.
Yep. Cool. So
I guess it is almost implicit there, then we didn't talk about it. The ability to defer paying off technical debt is one of the most powerful mechanisms for paying off the technical debt. Because that's if you can't defer paying off some technical debt, then you have to solve all of the technical debt of a code base. And then you get to a point where a project is technically bankrupt. Like, oh, there's no way we can solve this because it's almost starting it from scratch. There's so much debt. And so the ability to defer when you pay off technical debt is actually really powerful. And it's better than trying to pay it off right now. Because when you take something under such a huge scope as we're paying off all the technical debt, you are likely to bring in more technical debt of just in different places and bugs. And so, I struggle with it myself with the Boyscout principle. I go in there, I'm like, oh, it's not testable. I'm going to make it testable and I'm going to test it. Oh, look, I've uncovered bugs. I'm going to go fix those bugs. It's like, stop. Because then my PR gets blown up and it's 6 times the size it should have been. And 5/6 of that is paying off technical debt. And so the PR almost got turned into a whole other behemoth than what it was meant to be.
Yeah, it wasn't a tech debt ticket.
Those don't exist. People don't write tech debt tickets. I wish they would, but they don't.
All right. So, and actually on that note, one of the benefits of a microservice architecture, I guess, that we didn't ever talk about in the other episode, but I guess it's kind of specific to rethinking the technical debt, is like the idea if you have a huge code base that all relies on a specific framework and now you have to update the version for that framework based on security issues, and now you have an entire code base at the same time, you have to make sure all of it is going to be compliant with this new version by a deadline, like by the deadline when the other version is going to be deprecated. If you have like your smaller pieces of your smaller services, that have, different frameworks or different languages, I guess you can kind of, you have different timelines for when things need to be updated. You don't have to worry about like this huge deadline for everything to be updated at the same time.
So speaking of frameworks then, because I'm going to tell another little anecdote.
All right.
Same code base that I'm working on version 2. In version 2, I brought in a lot of technical debt because Django was the framework that's chosen.
Okay.
Partially, I'd never used Django before.
Yeah.
But it has leaked into everything down to the directory structure of the repo.
Oh, yeah.
Now, imagine this, okay? Imagine the hard drive you are writing to is now changing the structure of your project. Makes no sense.
Yeah, it's crazy.
The storage mechanism is a detail.
Yeah.
And so the database you're writing to is a detail. The fact that this is a web API is actually a detail. And those details should not be driving exactly what's being done. So if you could write your code that works in a way that it is framework agnostic. And like this is a concept that I'm toying with now because Django has just leaked into everything that I'm doing now, and I hate it because I feel like I don't have the freedom to do what I want. It's like, could I write something where it's, okay, I'm going to deploy this app as a Django app, or I'm going to deploy it as Flask and see how it works. And I'm really, I guess something I'm going to toy around with to see how it's doable, but
just completely abstract out the framework that you're using.
And that's what Django is doing. It's providing me an ORM for working with my database and, a web server not a web server, but, a REST framework. And like, that's what Flask is doing and SQL Alchemy would do in that version. So I want to see. Yeah. I think it's doable.
Rethinking the technical debt.
And I have an idea. And I think that, some of this code could be written. So it's like, Django 4 just came out. Well, the framework's just a detail in this code base. Let's deploy Django 4. Wouldn't that be cool?
That'd be crazy.
Cool. Okay.
Definitely something to research.
When I get it done, I'll throw it up on GitHub and we'll plug it.
Mm-hmm. Cool. So final section, we're finally going to get to these stats. So I thought it would be important to have a section where we translate technical debt from a developer concern to a business concern. Because, at the end of the day... This is the business
concern.
Yeah.
Those of you watching on YouTube, I'm rubbing my fingers together for money.
Yeah. Because, at the end of the day, as much as all the developers are identifying technical debt and have this gut feeling and noticing tight coupling and low cohesion, it's not going to be addressed unless the company wants to address it. So I think it would be good for companies to realize, and people in leadership and management positions to realize the benefit that they'll provide to their company when you prioritize technical debt, when you prioritize it being addressed. So there's numbers here. One of the other reasons for it that I kind of mentioned earlier is it's like, if you want good developers working for your company, they're not going to want to show up and work in a code base that just has all these problems and it's like totally messed up and you have to like go against all your morals just to work for that company.
The business trouble there is recruiting is expensive.
Yeah.
Like to get on all these services, to list jobs or to go find them, like that's actually a tangible cost. And Google doesn't do that. Everybody just wants to work for Google.
Yeah.
If you're known for like, oh, they have such good code, it's so easy to work with, like people are just going to apply, to work for you instead of you having to go out and advertise that people should work for you.
Mm-hmm. Yeah. And people are also like, even if you get people, if you put in the effort to recruiting and you get good developers to come work for your company and they show up and they're trying to find a way to make it work and they're trying to identify problems and identify problems and present solutions to management. Nobody listens. and nobody cares about the code and nobody wants to address the technical debt, well, your developer's not going to want to hang out and just work on awful code. You know, you're going to lose developers.
Exactly.
So those are some reasons, but let's also just talk about these numbers. So to start, we can identify the cost of poor software quality. So the cost of poor software quality can be separated out into some different categories. Technical debt is only one category, which...
So we should also say we've gotten these stats from a study that was done by the Consortium for IT Software Quality, and I love that freaking organization name.
Yeah.
So awesome.
Yeah, so this is a research article by people who... that's what they do.
This is how they've broken up or allocated the costs of poor software quality into these categories.
Yeah. So technical debt's technically only 18%. 37% of the cost of poor software quality is because of losses from software failures.
It failed because it had technical debt
that was not addressed. Yeah, so that's kind of the point that we're trying to get at. And then another 17% of the cost of poor software is because of having to fix and find defects. There will be less defects and less bugs if technical debt is addressed, you know? So technical debt is really more important than even this graph shows like initially. But they also have a specific section on technical debt. So there's a tool called the Cast Appmarq. We'll put a link for it because it's a pretty interesting concept that this tool has. So this tool calculates the cost of technical debt based on identifying structural quality problems in an application that, if left unfixed, could put the business at serious risk. So,
and that's how they bill it on their site, right?
Yeah, that's their website, or actually that's how the application was described in the research article. Okay. But yeah, we couldn't find anything super incredibly specific about how they identify that code quality is bad. But I mean, if they told us all, then we'd all be making our own Cast Appmarq products. Anyway,
get to the real statistic. The one that's my favorite.
Yeah. Okay. So, in the 2011 analysis of 1,400 applications containing 550 million lines of code submitted by 160 organizations. Lots of numbers. There's a lot of data.
They're just quantifying that this was a representative sample at that point is what they're doing.
Yeah. So
the dollars, dollars, Jordan.
Cast estimates that the technical debt of an average sized application of 300,000 lines of code is $1,083,000. This represents an average technical debt of $3.61 per line of code. And that is just in general. Java applications were higher at $5.45 per line of code. So that's pretty funny, I think. They specifically had to mention, oh, by the way, Java's like $2 even more than that.
Do you remember me talking a couple weeks ago about Java being a dying language?
Yeah.
Vindication.
Yeah. So anyway, I mean, these numbers, like over $1 million per 300 lines of code, that's a lot of technical debt. And that's a lot of money that could be lost if the technical debt wasn't addressed, right?
I'm straight up counting all the lines of code and all the code bases I work on.
Yeah.
Just to see if, we're close.
Yeah. So anyway, we'll post a link to that research article and the video and the Cast Appmarq tool. But yeah, that's everything. We wanted to rethink the technical debt, and this is what we have thought.
Yeah, it was very insightful. I really enjoyed that. I came up with a lot of the thoughts and ideas of fixing it, over the years of doing this, and that Adam Tornhill Tornhill talk. Tornhill, sorry. I apologize, I'm butchering your name. I was pleasantly surprised that he and I were very in line with our thoughts. He was a bit more knowledgeable and had more concrete solutions, but it's like, yeah, I'm getting there.
Yeah.
So that was a lot of fun.
Totally. And I mean, it's just, we have this developer perspective where it's like, let's make the code as cool and awesome and clean as it can be. But there are real ways and real processes to address it. And also business reasons why it's important. So hopefully if you're like some sort of manager and you've been thinking about tackling some technical debt on your project, hopefully we've convinced you that you can do that and it'll make people happy.
Yeah, it'll help build the team.
Yeah.
So
cool.
Definitely join us next time. We don't know what we're talking about yet.
I don't know. We'll have to talk about solid soon because we
mention it all the time. We should. And you're doing a talk on it.
Yeah.
On March 11th, Jordan is talking at the Austin Python meetup.
Thank you, Derek.
So yeah, we're really excited to see that.
We'll post a link for it.
Yeah. Did they say they could record it? I think they're recording it.
I don't remember.
But yeah, we'll definitely throw it up on the YouTube channel if we can, or share it.
Yeah. Or at least share the event. So if you're in Austin, you can come.
If you're not following us on Twitter and you want to get some sneak peeks like you got for this episode, namespace_pod on Twitter.
Namespace_pod also on Instagram. You find us on Facebook and YouTube.
And if you're not, like, if you've just been listening on Spotify or
we're on all of them now.
Yeah, Apple Podcast, iHeartRadio, any of those, and you haven't tried the videos yet, you should totally check it out. Because you will now get to see my total makeover of no hat and no goatee. Yeah,
I look the same every time.
Yeah, Jordan almost had a heart attack. She thought some stranger showing up to record, and it's like, who is this guy? Yeah, it was my second time seeing you without a hat. Right. But this is the first time. First time, yeah. I'm sure it feels nice. It's really hot out. If you haven't checked us out on YouTube, give it a shot. It brings a new element to it. Oh, I put a little animation at the beginning, and I worked really hard on that. She did, right? Not only is she technically savvy, very personal, but she also has a creative digital animation side to her as well. Yeah. We're so lucky to have her here. Thanks, Derek. We're lucky to have you. Sure. We are. It's awesome. Okay, well, thank you guys so much for listening. Oh, one more thing. namespace.pod@gmail.com. Right, yeah. If there's any topics you want us to cover, please let us know. Okay, thank you so much for listening. Bye.